Our first speaker is Karan Sharma, and he is talking an intriguing title, Going Above and Beyond. Over to you, Karan.
Cool, thank you. Thank you for joining. My name is Karan. So today I'm going to talk about, well, you will see. But before I start, I just want to say a big thank you to all of our sponsors, because without them, this conference probably wouldn't happen. A little bit about myself. I'm a pen tester by day. I do bug hunting in my part-time, probably at night. I've done offensive security, web expert, and OSCP courses, and I'm certified. I do web, mobile, and DevSecOps. That's my passion. And also, I love doing code auditing. If you would like to follow me, I'm root on Twitter, and I've got a YouTube channel as well, where I do talk about different courses and my review of other things as well. Quick disclaimer before I start the presentation. So everything that I'm covering in this presentation is solely for educational purpose. I take no responsibility how you choose to utilize the information that I'm going to share, but I'm still going to say, please be kind and responsibly disclose if you come across any vulnerability. Thank you. So these are the topics that I'm going to cover today. So the first one is HTTP request smuggling. The second one that I'm covering is JavaScript Prototype Pollution Attack. And the third one is around GraphQL API Hacking, how to do this. And the reason I gave my talk above and beyond name, because these areas are not covered in, or these vulnerabilities are not covered in OWASP Top 10. So that's why the title. So let's look into HTTP request smuggling, what that vulnerability is. It's actually originally documented back in 2005, but then the director of Portswigger Research, James, he sort of repopularized this vulnerability back in 2018 or 2017, I believe. This vulnerability arises when you could interfere with the sequence of the web requests that are sent to a web application or a website. It's like the way the website processes those requests or processes those sequences. If an attacker can interfere with that sequence, that's when this vulnerability arises. And if it's exploited, it could lead to things like you could bypass authorizations, you could steal cookies, you could steal session tokens, you could disclose information as well. It could be quite severe. Just to sort of dive more deeper into this vulnerability, today's web applications or websites, they have a reverse proxy, and then you have a backend application web server where your web application is hosted. Just for efficiency purposes, your front end forwards number of requests to the backend server on the same HTTP or network connection, right? Just keep that in mind, because what we are going to cover. So your front end is using the same TCP connection to forward several requests to the backend system. And your backend system parses those requests, because how would your backend system know what is the first request or what is the second request? It looks at the HTTP headers, and then it determines, okay, what is the first where the first request ends and where the next one begins. And the headers that are in play is the content length header and transfer encoding header. On the left-hand side, you're seeing the content length header, and on the right-hand side, you see the transfer encoding header. The content length header, if your request is using a content length header, your request is sent in one go. Whereas if you're using a transfer encoding header, your request is sent in pieces. On the right-hand side, the transfer encoding header, the word B that you see, it means it's the size of your request in hexadecimal notation. And that 0 at last is the end of the request. So that's how you represent a transfer encoding header. So how this vulnerability is caused, right? As I said, if an attacker manages to send a malicious payload which sort of confuses your front end and your back end, that where the first request ends and the second one begins, if there is a confusion, your attacker is going to take that opportunity to send its own malicious payload, because your front end and back end can't agree on the boundaries of those requests. That's when HTTP request smuggling occurs. So you would wonder how to actually perform this attack. Well, you have to place your content length header and your transfer encoding header into the same request, as you can see on the right-hand side in the screenshot. So what we are doing here, we are sending two requests in a single HTTP request, and we've got the content length header on the top, and we've got a transfer encoding header as well at the bottom. And then when this request is sent to the front end, if your front end checks for the content length header, it's going to ignore the transfer encoding header, and it's going to pass that back to the backend server. And if your backend system only checking for the transfer encoding, it's going to ignore the content length header, and it's going to start parsing the request based on the transfer encoding header. So as you can see, there is a confusion there. Right? So this is what happens. Also, to take it up a notch, you could also sort of add some ambiguity to your headers as well. So it confuses the front end and the back end server even further. So that's when this attack can happen. To illustrate it more, you can see there is an attacker requesting a resource probably from a web application, and then at the bottom you have a normal user. But when an attacker is actually accessing something from the web application, it's also sending a malicious payload. Sorry, I don't know what happened. Yeah, so on the right-hand side, you can see the attacker's payload is actually added on top of the victim's request, because there's a confusion on the backend, because the backend system doesn't know where the second request starts. So it's waiting until a normal user requests a random resource, and that request that attacker sent is actually added on top of that. And whatever is in that payload, it could be a universal redirection, where attacker sent a payload to redirect your user to an attacker-controlled website. Or an attacker may have a payload that lets you send your cookies to an attacker-controlled website. So you would probably give up your session cookies, your API keys, or they may ask you to perform some unauthorized access as well. So that's what can be done. As I said, front-end and the back-end servers, right? So your front-end server could only, so this attack can be divided into these three parts. Your front-end may check for CL, stands for content length, and back-end checks for transfer encoding. Or vice versa, your front-end checks for transfer encoding and the back-end checks for content length. But if both are looking for transfer encoding, then you can fool that header which is in the request to do something dodgy, and that's when it gets confused. Your front end will get confused and will pass that request to the backend system, and then it will process the request based off the payload that you have in that request. To illustrate further, to dive further deeper into this attack, as you can see, we've got an attacker on the left-hand side. It's accessing a random site, and the attack that we're talking about here, your front end only checks for the content length header, and your back end checks for the transfer encoding header. And as you can see in the request, what we are doing, we are sending two-part request. We've got the content length header, and we've also got a transfer encoding header. And as you can see in the front of the transfer encoding header, we are trying to do something. We have added a header in front of the transfer encoding, which is going to fool the front end. As an attacker, we are just posting to a login endpoint. But in the bottom of the request, as you can see, we are also requesting a random resource, which is robots.txt file. And your front end is going to look at the content length, and your request in the back end would be poison, because your backend would look at the transfer encoding header, and it's going to say, oh, okay, the request actually ended at 0. And now that the bottom request, which is robots.txt, it's like sitting there on that connection. And what happens next? Well, so that's there, so that request sitting there, now your regular user is going to interact with that website. And that user requests a resource like his own profile. He's going to like profile endpoint, but as you can see on the right-hand side, robots.txt is still there. And when this user is requesting the profile endpoint, the backend is actually serving that user the robots.txt file because it's poisoned. And that user will go to robots.txt. This is just a general indication like how the poisoning would work, but that could be anything. That could be a poisoned website that's under attacker's control, and your user will be redirected to that particular website. So there's been a number of attacks like these in the recent years, like back in 2020, 2019. There's a heaps of researchers finding these vulnerabilities on the bug bounties program, and the payout is quite high because this attack is quite dangerous. I hope this makes sense what I just explained. So how the poisoning works, right? How do we test for these smuggling vulnerabilities, right? Obviously, like these smart guys like Dev Param, he presented this vulnerability last year on the HarmCon's conference as well. He also created a safe way to test these vulnerabilities. So he created a tool called Smuggler. So you pass the domains that you want to test request smuggling against, and then it does it so safely. Because this attack could be quite dangerous, where you could actually really interrupt the day-to-day operation of the website. So it has to be like tested in a safer manner. Then James also created a Burp Suite extension called HTTP Smuggler. And you could just, I think it's available for the community edition as well. And you could test this particular vulnerability in a safe manner. And James' research that he originally published has quite a few other ways to detect this vulnerability in a safe manner. If you are interested in this vulnerability and you want to practice more and you want to learn more about it, I've just put these few topics, links there. So the first is the talk that Dev Param did at HarmCon last year. It's really, really cool talk. He goes like quite deeply into this vulnerability, and he also talks about how he found these vulnerabilities on bug bounty websites. And then Web Security Academy from Portswigger, they have a number of labs on HTTP request smuggling. And you can practice that for free, and a few other talks as well. So real-world exploitation, like where this vulnerability was used to exploit, the websites or other areas. MDM compromise, one of the best articles that I came across, which actually highlights the severity of HTTP request smuggling, as you can see. And then the Slack has this vulnerability where you could actually take over a number of users at the same time, and a few others. I've linked all the reports as well. These are publicly disclosed. And how to protect against this vulnerability. First of all, don't reuse the network connection that you have with the front end and the back end, right? Because you don't want to reutilize what was sent previously, and you want to send the same request again on the same connection. Use a single connection every time. Use HTTP2, because that would help you with ambiguity. Like, it would prevent against that. It would actually help you determine where the first request ends and the second one begins. So that's available in the HTTP2 header. Try to use, if you're in this scenario where your front end and the back end servers got web servers installed, like say if you're using IIS 10.0 and IIS 10.0, try to use that same version in your front end as well as in your back end, so they agree on the boundaries. Maybe it's not applicable in the scenarios where you're using reverse proxies, like you may have F5s and the others and stuff like that, so that might not be applicable. But if you have a front end that uses a web server and the back end uses a web server, then try to match the server versions as well. And the next thing that you can do is try to normalize the requests from your front end before it hits the back end server. Try to sort of scan the headers, and that would help against this particular attack. Hope that makes sense. So the next attack I'm going to talk about is the JavaScript Prototype Pollution Attack. How many of you have heard of this attack before? So JavaScript, everything in JavaScript is an object. And what's not object, or the 6 things that are not objects, are called primitives. And what are those? Those are like JavaScript types, like null, undefined, strings, numbers, boolean, all other data types that are available in Java. 6 things. These are called primitive types. So JavaScript is prototype based. That means if you create an object in JavaScript, it carries over properties and methods from the global object or prototype object. So these prototype objects have some basic functionality, like you can do toString, constructor, and has on property. You could run these methods on top of these objects. So you would wonder, like, what's this vulnerability is, right? We'll dive deeper into each vulnerability, but just to give you an overview how this vulnerability arises is when a user-controlled JSON object, you say, user is inputting something to your web application, and a user-controlled JSON object ends up in your merge, clone, or other operation, like those, like how you would have like eval operation, for example. If the user-controlled object ends up in any of that operation, that's what leads to a JavaScript prototype pollution attack. So once that object is modified, once that prototype is modified, any object that you create afterwards would also be impacted. It would also carry over the same properties that you will have on the global object, and we will see how. And as usual, yes, it is a bad practice to make changes to the global object or overwriting the prototype. And obviously when the attacker modifies that, that's what leads to the prototype pollution attack. I know that's what you're thinking, right? And that's exactly why I wanted to actually take you step by step what's happening. Hopefully it works. Okay. Right. So what I'm going to do here is I'm just simply creating an empty object, because everything in JavaScript is an object. So just an empty object, X, nothing there. And now I'm going to create an object. What is object? Object is an instance of a class, right? Object has properties. Here, I'm creating a person object. And the person object will have 2 properties, the first name and the last name. Right? And then, these properties can be accessed as I'm doing here with dot notation. So person object dot property, and it will give me the output of that property, right? Simple. So that's what an object is, and that's what the properties are. So there is a thing called constructors. Obviously, all the developers, those who are here, they know. Similar to your regular functions, but with constructors, you can create new objects. Right? It's just like a skeleton that you want, how you want to create your new object. So that's the skeleton for your objects. One thing to remember here, though, your constructor's name has to be in uppercase. That's just the standard or good practice. Well, that's what I learned in the JavaScript course. So that's what I'm going to do now. I'm just going to create a constructor here. As I said, the constructor name will be in uppercase. So I'm creating a constructor called car with 2 properties, make and model. Spelling mistake, but I think I correct that. And then we use the this keyword to set the properties of the whatever we want. Then we use the this keyword and the property. And whatever is passed in the constructor is actually directly passed to whatever the statements are in the this keyword. Right? So that's the constructor that we have created. Simple. Now, we are ready to create objects. Just going to fast forward a little bit. So here, I'm creating a new car called my car, and I'm giving the property make here, and then model. I don't own this car, I just randomly thought about it. And then if I click on my car, it's going to give me the values of what I've passed, right? So that's my car object. I hope you're still with me. And then again, as usual, you can still access a single property on an object. My car.model, my car.make. And similarly, because it's a constructor, you can create another object. And here I created your car, and I give it to Nissan GDR, and you can do exactly the same thing. Cool, so that's what constructor is. So like we created two properties, not these properties, but if we want to create more properties, like say you want to add a year to your object, how would you do that? You have few options. One is you go directly to that object and you add a property. Second thing is you go to your constructor and you modify your constructor and add a property, and then recreate all of those objects. Or the third option is that you utilize the JavaScript's powerful option that's called the prototype. You make changes to the global object and you add property to that, and every object that you've created will inherit that particular property. And let's see how. So as I said, my car, that's my car, holds those two properties. Your car holds those two properties. And this is the constructor that my car used to make itself, right? So that's the object that we used, as you can see. And similarly, your car is also built using the same constructor. Same values, right? As I said, we can add a new property by simply adding another property to an object. So we are adding a property called year to an object called my car. This is first one way to do it. But this property wouldn't be available on your car, and we will see. But now we've got three properties here. But your car will only have two properties because we've added that property directly on that particular object. So how do we do it? And here, you would start to see the proto and the prototypes on these objects, or the constructors. And this is the prototype of your car constructor. And that's exactly the same thing. Now, see, we are adding the year property to the prototype of the car constructor. And now, that property will be visible to your car as well if you do your car.year. And that's the beauty of the prototype, and that's the beauty of the JavaScript prototype. And that's where it's useful. Because now, if you create any object, it will have access to that particular property. Right? Okay. So, we've created an object, we added the properties, we modified the prototype, and we've got these two values. Right? So one that we manually added, and this one we added through the prototype chain. Just going to fast forward quickly so we can cover it. So here you're seeing the object that we created called my car, then we access the constructor of it, and then we access the prototype of it, and then similarly we've done the same operation on your car object, and the output is the same, right? But when we look at the values of the your car and my car, it will be different, as you can see in the upcoming steps. You would see that. And the way JavaScript access or JavaScript knows which properties it needs to access, it does it through the chains. We are doing the get on property operation on your car, and we are doing the get property names on my car as well. And as you can see, there's a difference. There's a difference here, right? And it's going to keep going until it finds the property. It's going to keep going one step above, and then if it finds the property, and it's going to stop there. Don't worry if it still doesn't make sense, but I will explain a little bit more. So here I'm just going to show you quickly how to pollute this. Here I'm adding on the top of the object a property called AppSec, and I'm assigning that property a value called AppSec is awesome, right? So that's been added. I'm not going to touch the new object. All I'm doing is I'm just creating an empty object here. A Y object, an empty object. And you would see the power of JavaScript prototype. Y.appsec, if you access that, it's got that property populated. That's called the JavaScript pollution attack. Because you could see that the property that we added to the AppSec here, every object that you would create from now on will have access to that property. And that's when the pollution happens. Because imagine now, if you have any sort of implementation in your web application where you're allowing users to pass you objects in the input, like JSON objects and whatnot, and if a user has the ability to infect your prototype chain like this, every single user who's interacting with your application will have those objects inherited going forward. That's what JavaScript pollution attack is. Just to show you one more thing. A very basic application, right? Here, all we are doing is we are saying user is equal to user ID 1234. If a user is administrator, or if a user has this property called admin, or if user.admin is equal to true, console.log you are an admin, right? So it will give you that. Well, our if statement didn't execute. Why? Because we are not admin. That admin property doesn't exist on the user. Well, that's fine. What happens if we have the ability to perform pollution attack, JavaScript pollution attack, prototype pollution? So here, we have polluted the admin property. We added that to the top object, and we set the value of that property to true. And what's going to happen? We are polluting that, and now that user's value of user.admin will be true, and our statement will be executed. And that's when the JavaScript pollution, prototype pollution attack happens. So it could also bypass your authentication. It could also lead to authorization issues as well, if you allow users to control how the JSON objects are passed to your web application. So it's quite dangerous. So what is the impact, as I was explaining, right? It varies from your application to application. It depends on your application logic, how your application is handling these objects, or where those objects actually end up going. Could also lead to cross-site scripting attacks, can bypass authentication and authorizations. And again, it does affect your front end. It can bypass the sanitization, and it also impacts your back end as well. If you are using Node.js, it could also lead to remote code execution. And there are a number of ways through JavaScript prototype pollution attack to DOS your application as well. Real-world exploitations, you could see there have been a number of exploitations in the past. It was also found in jQuery. I think it was also found in Lodash as well, and few known vulnerabilities from recent times where it is found. It's really less known attack. Not many people know about it. but it's quite damaging. How to hunt? How to find these vulnerabilities? Well, there is a very good lab that you can spin up on your laptops, and you could try to play with JavaScript Prototype Pollution Attack to get more understanding. There's a really nicely written browser extension which allows you to perform this attack, and please do that on your own risk, because if it finds the vulnerability, it's going to impact that particular website straight away, and that's going to be for every single user that's going to interact with that website after you finished your attack. So please be mindful. And really good research as well on this topic here. So how do you prevent against these things? Just like your regular sanitization issues, please make sure that you sanitize user input every time you receive something from the user. In this case, it could be in terms of JSON objects. Make sure that the user's input doesn't end up in the unsafe, those eval type critical operations or merge operations. No NPM audit. Hope everyone knows about it. Please make sure that you run NPM audit against your projects before you push the live button. All of the stuff is there. GraphQL. Well, it was an internal project for Facebook back in 2012. I guess they originally made it open source. It was originally an internal project, and then it was open sourced in 2015. So GraphQL is your data query language for your APIs. They say that it's more efficient compared to REST. Still debatable. For example, why it's more efficient, like say if you want to fetch ID, probably the posts or the followers on a user or probably from an endpoint, in a REST API, you will make 3 different calls. Whereas in GraphQL, you would only make 1 call and it'll fetch all the information for you. So that's why it's probably more efficient. Let's take a closer look. Here, in the user's endpoint, we've got an ID endpoint. So /user/ID endpoint. And we want to fetch the ID. So that's one request. We're doing a get operation on that. Then we need to fetch the post. We make another request. This is a REST API. And then we also need to fetch followers. And then we make a third request. So that's a REST API. In GraphQL, you specify what you need in a single request, name, post, title, followers, whatever, like that's your structure, and everything is fetched in single request. So that's the difference between REST and GraphQL. So what happens when you have a GraphQL endpoint, or you may have like your own GraphQL endpoint and you want to know what you can do with it? In GraphQL, there's a thing called introspection. By default, you should be actually turning it off. But if that's left enabled in your production environment, anyone who has got access to your introspection, they can understand the schema of your API, like how to call it, how to query your data. Everything that they need to call your API is actually there in the introspection. So please make sure that it's turned off. Or if you have interactive GraphQL endpoint available, then there's simply go to like a docs section. It's on the left-hand side. And then you can fetch all the information that you need regarding how to construct your query. So a couple of things that you need to keep in mind if you ever come across a GraphQL endpoint. First is introspection, and the second is if it's interactive, that's what you can do with it. And obviously, if it's not there, if introspection is turned off and it's not interactive, well, do it manually. Or look at the GraphQL IDE. There are quite a few things that are available in GraphQL IDE. Or there's a very good script written by Doinsec, which you can use to understand how the schema is built for that particular API, or how that would look like. Quite a bit of a really nice script if you read the code of that script. But that would definitely help. Vulnerabilities, like what sort of vulnerabilities could arise in in a GraphQL endpoint? Well, all of these, like what you have in REST APIs. You still have indirect object reference, IDORs. You could still perform SQL injections or NoSQL injections. You could still do information disclosures. Broken access control, similar to probably authorization bypasses. The last two things are more around the implementation of GraphQL, because it's like how nested the GraphQL query can be. And if you like have ability to make it nested, and further nested, it would take longer time to process in the back end as well. And plus, it's going to use quite a bit of compute. So these are the issues in the GraphQL APIs that you could come across. Example, as you can see, user ID is equal to something. And if you have ability to change it, and see if you still get the response as a logged in user. That will lead to indirect object reference or IDOR. Not just in the ID, but you could also look to change any primary key that you come across in an API. Could be ID, could be UID or whatever. That will be IDOR. A SQL injection example, by adding a single quote. Try putting single quotes everywhere and see if the application cries. As you can see on the right-hand side, we've got the database error, your typical SQL injection error. It could be blind as well, so please don't rely just on the errors. Sometimes there is a CLI, but you wouldn't get a response back. So that's your blind SQL injection. In those scenarios, you could choose to use the sleep payload and see if the application sleeps for 10 seconds or 5 seconds before it gives you a feedback back. That's how you could test for blind SQL injections. Another way to test it, you could feed here. We've got the SQL payload, union select current user. It got executed on the right-hand side. You can see that in the response. Yeah, so just to give you an idea that, yeah, these are the attacks that are possible in a GraphQL API. Some real-world exploitations. So just taking these from HackerOne, publicly exposed reports. The funny one was the internal beer consumption. So through the GraphQL endpoint, they found how much beer they consume internally. That was quite cool, I thought. And they paid $802.20 or something. I don't know. Could have just paid $800. And yeah, this as well. So like, there's a decent payout if you come across any GraphQL API bugs. So how do we fix these issues? Rate limiting, like that's a common practice these days, like limit how many times you can call a particular endpoint, whether it's a REST API or GraphQL API. We should either ban the IP or just like slow down the requests, or could just allow 10 requests per minute. Obviously, that's a no-brainer. Turn off your introspection, don't leave them on. Because if that's there, then, that gives away quite a bit. Depth limiting, as I was talking about, how deep you can go to query data on a GraphQL endpoint. And query cost limitation, again, that's probably directly proportional to how deep you want to go into a GraphQL query. And I've linked a few references for you if you would like to go do your further research, or the things that I've talked about. If any of that you want to find more about, it's all here in these links. And thank you. That's all from me today. Thank you. Thank you very much. Cheers, mate. And if you have any questions, please see me after, or if there are any questions on the board. Yeah.
Do we have any questions?
Look, they understood everything.
Clear, yeah, clear as day. Thank you very much, Karan. Thanks again.
Thank you.